Hello, this is physics, and this is our suggested problem set for Unit 0, suggested problem set number 1. So I am looking at question number 15 in our text, and we're starting with part A that says, suppose a person has an average heart rate of 72.0 beats per minute. First question says, how many beats will this person have of their heart in 2.0 years? So if I have this many beats per minute, I need to know how many beats per year that is. So I'm actually going to do a little bit of a unit conversion, and I can do that a couple ways. I could either find the number of beats per year, or I could find the number of minutes in 2 years. So I'm actually going to do that, because that seems a little better. So in a year, I have 365 days. In a day, I have 24 hours. And then in an hour, I have 60 minutes. So if I multiply all of these together, I can actually see that the years unit would cancel out, the days unit cancel, the hours cancel, and I have only minutes left. So this actually tells me how many minutes are in a year. So multiplying 2 by 365 by 24 by 60, I get the huge number of 1051200. So there's 1 million minutes in a year. So the next bit is, how many beats do I have in that year? So I'm going to take my 72.0 beats per minute and multiply by this huge number, 1,051,200 minutes. And again, you can actually see that my minutes part would cancel out. And so plugging this into my calculator, I get a huge number, 75 million. So 75,686,400. And that's beats. But thanks to significant figures, I really should not report this number. So out of the two numbers that I started with, the 72.0 and the 2.0, I only have 2 significant digits or significant figures in one of those numbers, or 3 in the other. So my answer, I can really only have 2 significant digits in the end. So what I really should report with significant figures is 76 million. And of course, in order to do that, in order to round here, I'm just going to start counting from the left. So I have 1 significant digit for the 7, and then here's my second. So I'm going to round to this place. The next digit is a 6, so I round up my 5 to a 6. So I'll do the same thing for part B. Part B says, what about in 2.00 years? So I can actually use this exact same number. I'm just going to round it to a different spot. So instead of 75,686,400, I'm going to round to the third significant figure spot. So 7 is 1, 5 is the second. So now I'm actually going to round to this 100,000s place. So I look at the next digit, it's an 8. So I'm going to round my 6 up. So I should round this with significant figures to 75,700,000 beats. And that's my answer to B. So if I go and look at C, now it says 2.000 years. Now the thing that's weird is that I was also given this 72.0 number, which means that in this case for C, the least number of significant figures actually comes from that 72.0 number and not the number of years. So in actuality, my final answer is again going to have only 3 significant figures. So I can use the exact same answer I just had for B for part C, because it should have the same number of significant figures. So, continuing on, 16 says a can contains 375 milliliters of soda. How much is left after 308 milliliters is removed? So this is a case where we're working with addition and subtraction. So the funny thing is that this is actually a really easy question. And even though it looks easy and it is easy, you really can second guess yourself on this. Plugging this into a calculator, I just get a really simple answer of 67. And that's, of course, milliliters. The rules for rounding with addition subtraction are look at the least number of decimal places. Both of these numbers have 0 decimal places, right? Both of them. Which means my answer should have 0 decimal places. And it does. So I'm done. There's nothing special at all for this one. So even though we have these significant figures for rounding, sometimes you don't even need them. Looking at number 19. I have a speedometer that says I'm traveling at 90 kilometers per hour. What is the percent uncertainty? Well, if the uncertainty is 2 kilometers out of that, I'm just going to take my uncertainty, which is 2 kilometers per hour, over my speed, 90 kilometers per hour, and then to make it a percent, I'm going to multiply by 100. So 2 divided by 90 multiplied by 100 is an uncertainty of about 2.2%. Or I could do 2.2 repeating. It doesn't quite matter. Now, how does this change when I'm actually going at a lesser speed? Well, B, if I look at the same percent uncertainty of 2.2%, the range of speeds that I could be going would be either 2% above, which would be 0.022 times 60 plus 60, or 0.022 times 60, and then subtract that from 60. So the range of speeds that I could be traveling actually goes from 61.32 kilometers per hour down to 58.68. You have trouble reading my calculator here. So this is the range of speeds that my car could be traveling if I have 2.2% error. Continuing, 22 says, what is the area of a circle that is 3.102 centimeters in diameter? So first off, I'll remember that the area for a circle is pi times radius squared. So this is given as diameter. So first I'm going to find my radius, which is diameter divided by 2. So 3.102 divided by 2. Now I don't need to worry about rounding here because the radius is always exactly 1/2 of the diameter. So it doesn't matter if my significant figures change. So I have 1.551 centimeters is my radius. So now when I plug this into my area, I'm going to have pi, I'm just going to use the symbol pi because I have a calculator, times 1.551 centimeters squared. So squaring this and multiplying by pi on my calculator gives me a number that goes on forever. It gives me 7.557418429, and I'm sure it goes on, but that's all my calculator can even tell me. So how do I know what to round to? Well, if I look at the original number I was given, the 3.102, this number has 4 significant figures. That's the only number I was given. So mathematically, my answer should be rounded to have only 4 significant figures. So counting from the left, 1, 2, 3, 4, I'm going to round to this place where the 7 is. The next digit is a 4, so I'm going to round it down. So with significant figures, the area for my circle should be 7.557 square centimeters. Again, that is because my original number has only 4 significant figures. So, let's keep using these significant figures. 23 says if a marathon runner averages 9.5 miles per hour, how long should it take to run 26.22 miles, which is a marathon? So I'm going to take my 26.22 miles, and I'm going to divide by that speed that this person is going, 9.5 miles per hour. So I can actually see that my miles cancel, and I have 1 over an hour in the denominator, which brings it up to the numerator. So I'm left with hours, so my answer is going to be in hours. When I plug this into my calculator, 26.22 divided by 9.5, I get an answer that says 2.76 hours. So this is not my final answer, however, because out of my numbers that I was given, this number has 2 significant figures. So I actually need to round this to have only 2 significant figures. So I will round 1, 2 to where the 7 is. The next digit is a 6, so I'll round it up, and I will report my answer as 2.8 hours. All right, getting close to the end. So this last bit, I'm making a small rectangular box with these measurements. So in case you've forgotten, this is what my box is going to look like. And so I have 3 measurements, and the volume of this is going to be length times width times height, so I'm just going to multiply these numbers together. So I have 1.80 times 2.05 times 3.1. Plugging this all into my calculator, I get a value of 11.439, and that will be centimeters cubed because I have centimeters times centimeters times centimeters. Now, with significant figure rules, all I need to do is look at these original 3 numbers. My first number has 3 significant figures. My second number has 3 significant figures, but my last number only has 2. So I actually need to round my answer to have the least out of those numbers, which is 2. So the volume that I'm going to report is actually going to be rounded to where this 1 is, the 1's place. The next digit is a 4, so I'll round it down. So my volume I can only report to be 11 centimeters cubed.